once we get to know about the origins of complex numbers, just like we were about to add real numbers after learning about real numbers, we can start adding and subtracting complex numbers. So if you have two complex numbers, let's take z1 to be equal to 3 plus 2i, and the other complex number, let's name it as z2 and let's write it as 5 minus 6i. You want to find the sum of these complex numbers. So what do we do now? So basically, the idea behind complex number addition or subtraction will be to deal with the imaginary and the real part separately. So in other words, what it will mean is to add these two, we will first, let's start by adding the reals part. So the reals part of z1 plus z2, the reals part of z1 plus z2, that will be equal to the real part of z1 plus the real part of z2. And so in this case, that will be equal to 3 plus 5. That is the real part. The imaginary part, just like the real part, the imaginary part of z1 plus z2, again, separately add them. So imaginary part of z1 plus imaginary part of z2. So you write the I here, and in the brackets you write the imaginary parts. So from z1 you get the contribution of 2, positive 2, and from z2 you get the contribution of negative 6. So negative 6. Solve for this. 3 plus 5 will be equal to 8, and 2 minus 6 will be equal to negative 4, and this times I. So the sum of these two complex numbers is equal to 8 minus 4i. Now if you wanted to subtract these, you just need to replace the sums here, the plus signs here, with minus signs. So there is a minus, there is a minus, there is a minus, there is a minus. You don't need to do anything except while we were adding element-wise, you were adding the reals first and then the imaginary. Now you will take the difference of the reals first and then the imaginary. So if you wanted to figure out z1 minus z2, what you can do is you can just do the element-wise subtraction. First, let's start with the reals. So the real of z1 is 3. The real of z2, that's 5, but you have to subtract them. So 3 minus 5. This plus I, we're taking plus just for the sake of convention, so that we have some sort of uniformity happening around here. And then from z1, the imaginary part of z1 is 2. From that, you're subtracting negative 6, so minus negative 6. This is equal to, well, 3 minus 5 is equal to negative 2. 2 minus minus 6 is equal to 8. So you have negative 2 plus 8i. This is the difference in z1 minus, and it's the difference z1 minus z2. If you went on to find the difference between z2 and z1, so that is z2 minus z1, what will this be equal to? So what do we do now is, let's start with the real part of z2, so that's 5. Subtract from it the real part of z1, so that's 3. Add this, the imaginary part, so negative 6 minus 2. This here, 5 minus 3 is equal to 2, and minus 6 minus 2 is just negative 8. Negative 8 times I is negative 8i. And so the two differences are just the opposite of each other. So z1 minus z2 is equal to negative of z2 minus z1. You can, in the same way, you can find the commutativity of the addition, and that's something I forgot to mention. But anyways, if you added z1 after z1 to z2, except for having 3 plus 5, you would then have 5 plus 3, and except for having 2 minus 6, you would have negative 6 plus 2, and Since commutativity holds for real numbers and complex numbers arise from real numbers only, the commutativity of addition of complex numbers also holds. Let's do one more example of summing up these complex numbers. So we have, let's take cos of 30 degrees plus I times the sine of 30 degrees. That's the first vector. And the second vector, let's say that's equal to cos of 60 degrees plus I times sine of 60 degrees, just making up these numbers. And so if you wanted to add these two complex numbers, so z1 plus z2, what will this be equal to? Well, the real number side, that's equal to cos 30 plus cos 60, cos 30 plus cos 60. The imaginary part, that is equal to sine of 30 plus sine of 60. If you wanted to solve for this, you can. So in that case, cos of 30 is equal to root 3 over 2. Cos of 60 is equal to 1/2. And in the imaginary part, you have the sines. So sine of 30 is equal to 1/2. And the sine of 60 is equal to root 3 over 2. And what you can do is you can also take root 3 plus 1 over 2. Since this thing is common in both the reals and the imaginary part, you can take that out and you can write root 3 plus 1 over 2 times 1 plus I. This is the sum of these complex numbers. If you wanted to take out the difference, so if you wanted to find z1 minus z2, except for having these positive signs here and here, you will just put the negative signs and nothing else will change. This positive sign with the I will just remain as it is. Don't touch that. This positive sign is going to remain there. And instead of having the pluses here, you would have the minuses. So minus, minus. And if you look at this closely, this right here, the real part is equal to root 3 minus 1 over 2. This right here, the imaginary part, is equal to 1 minus root 3 over 2, or this is just the same thing as negative of root 3 minus 1 over 2. Take root 3 minus 1 over 2 to be common, root 3 minus 1 over 2 to be common, and you will leave behind 1 and a minus I. So I hope this gives you an idea of the addition and subtraction using analytic methods of these complex numbers. We'll continue talking about arithmetic operations. We'll talk about products. We'll talk about dividing complex numbers in the next videos.